Good afternoon, everybody. Welcome to Manage and Troubleshoot Your Windows Server Environment Remotely. My name is Andrew Mason. I'm a Principal PM Manager in the Windows Server Group, where I work on Nano Server and remote management. And joining me today is
Samuel Lee. I'm also a Principal PM in the Windows Server org, and I work primarily on server management tools.
So if you've been to any Windows Server sessions this week, you've probably seen this slide already, where Windows Server offers built-in layers of security, a software-defined data center, and cloud-ready application platform. Management cuts across all of those. We're not really going to specifically dive into any of those areas in any detail, but we're going to talk about management in general, which applies across those. So what we really want to talk to you about today is we've got a little bit of an overview, and then we've got a new set of tools that we've been working on for a while now that are available in public preview, and there's a demo and a booth down in the expo hall. How many people have heard of server management tools before? A few hands. How many people have tried it? Okay. It's hard to see up here, so I think I saw a few hands. So we're going to spend a lot of the time in this session on the server management tools and do some in-depth demos and things and really explain what it's all about and hopefully answer all your questions. We will have some time at the end to take questions. I can't really see up here, so we won't know if anybody's trying to scream out a question, so please hold those to the end and we'll get to them. And then we'll spend a little bit of time on remote server administration tools, or RSAT. That's been around for a while for the previous releases of server. There'll be a new version for server 2016. Then we'll touch a little bit on some of the improvements in PowerShell and some of the other tooling that we've been working on for Windows Server 2016. And then at the end, touch a little bit on Nano Server remote management, how a lot of these improvements in the remote management benefit the Nano Server installation option.
All right, thank you very much, Andrew. So just a quick overview, just 3 very simple points. First is we're really in a time of transition all throughout this week. I mean, you've seen the signs, you've been in the sessions, you've been in the expo hall. Everything is focused on the cloud, where the industry is heading from a cloud-based perspective. What are the scenarios that we need to cover? What are the benefits for you as the customers to enable your businesses to run your IT infrastructure and leverage the power of the cloud? And so this cloud focus, for us particularly, is interesting because a lot of customers are thinking about hybrid cloud and what that means, right? Hybrid in the sense of you've got existing investments in infrastructure and Windows servers, on-prem and data centers, but you also want to take advantage of what the cloud can offer you. And so in this context, what we want to do from a server management perspective is also leverage the power of the cloud. So we've been investing, as you'll hear more in this session, in a toolset called Server Management Tools, which is an Azure-based service. It's got Azure consistent UX with all the other cloud investments that Microsoft is putting in Microsoft Azure. PowerShell, of course, is obviously a key focal point in this cloud environment for management at scale and for broad coverage of the manageability tasks that you want to perform. Another advantage of the cloud is the ability to evolve the management tool set over time. It gives us the opportunity to have an agile delivery schedule because we are not tied specifically to a box product release schedule. And of course, it allows us to address current and future customer requirements, and again, at a much faster rate than we could in the past. So within this time of transition, we're putting our investments in these types of tools. But what about all the existing tools that are out there that you guys are used to using? Think of MMC. It's taken more than 15 years to accrue value in the MMC ecosystem. A lot of what you do typically for server management tasks is really based in MMC and has been for a long time. How do we move those investments and the expertise that you've built in using those tools in the new cloud-based environment, right? The set of tools is so large, we need to really figure out what is the right set of functionality, what are the key priorities that we need to move forward into this new cloud-based or hybrid mode of thinking and of managing servers. And finally, one of our goals, 2 of the main goals for our platform investments moving forward is really around extensibility and flexibility. If you think about MMC, one of the reasons why it was so successful is because it provided a platform not only for Microsoft teams to build their management tools, but also third parties to plug in. And that has provided over time the consistency for customers when managing various things and infrastructures in their environment. So what we want to do in our future investments as well is obviously establish a platform on which that kind of ecosystem can be built out, again, in the cloud world. Flexibility is key. What we mean by flexibility is the fact that we want to support not just traditional on-prem environments, but we want to support things that are born in the cloud, Azure VMs. We want to support private cloud deployments like Azure Stack, and any combination of those in whatever hybrid configuration you choose for your environment. So, server management tools. As Andrew mentioned, we're going to spend at least half of the session talking through the details of what this is, why you might be interested in it, and why we believe that this is really the future of server management. So, first of all, what is server management tools? Before I get into that, I just want to say thank you to all those people who have stopped by our booth in the expo hall these past few days, and for those who participated in various focus groups where we talked about server management tools. It's really been eye-opening for me, just the kinds of conversations we've been having and the types of questions that you guys have raised through the booth conversations and through the focus group. It's given me a lot of insight into, I think, where we need to focus next and what some of your requirements are in the context of what we've already built.
And just related to that, we have a user voice area for remote server management. So if you haven't given us feedback this week or you have further feedback when you get back to your offices, please use the channels to give us that feedback. We want that to help us figure out what tooling we should put into these.
Yeah. And I'm going to repeat that several times
Probably.
As we go through the slides and demo, because it's super important for us to be able to get that insight directly from you guys, our customers. So in those conversations at the booth, I've had some great questions from you guys, and I've tried to answer those. And what I'd like to do is actually, when I go through the slides and the demo, at some points I'm going to go off script a little bit and try to actually raise some of the questions that I've heard from you guys at the booth and at the focus groups, and try to answer those as we go along. Of course, we want to try to leave some time at the end as well for additional questions, and we'll certainly try to get through everything so that we have some time at the end. So one of the themes you've probably heard this week is, Microsoft, we want to be cloud ready when you are. And that concept also extends into the management tools domain. If you look at this diagram, every time this little infographic there, it's going to show up in various places, but I want you to remember, whenever you see this, just think Microsoft is cloud ready when you are. So from a server management tools perspective, what does it mean to be cloud ready? If you think about the title of the session, remotely managing from anywhere in the world, managing from any platform, because it's web-based, it's hosted in Azure. You could be, on your MacBook at the airport or on the beach, on the Safari browser, and you still get the same consistent Azure UX as you would on a Windows laptop. The other aspect of what we're doing here is really managing your servers, which may be geographically dispersed across different environments. You should be able to connect to and manage your servers in a traditional on-prem private network or data center. But you also probably have some Azure VMs running in an Azure virtual network. And also, possibly, other third-party networks or clouds, private or public, including AWS, right? Amazon EC2. So we want to provide a way in this cloud-based hybrid model for you to be able to see all your Windows servers, regardless of whether they're physical or virtual, all together in one place. Oh, and I didn't mention this, but the best thing about this is it's completely free. It's not just a free trial, but it is a free Azure service. We will not charge you for any usage of this service.
So you do need an Azure subscription, though, right?
I'm about to get there.
Okay. Stealing the thunder, sorry.
All right, so server management tools. Let's get into some more details. It's a web-based remote management toolset offered via Azure. As Andrew pointed out, even though it's free, you do need a subscription, but there are various subscription types offered through Azure. And so you could either get a free trial, or what you can do is get on a pay-as-you-go subscription. And the way pay-as-you-go works is, depending on which Azure services you onboard and leverage, each of those services will charge you and bill you differently based on how they define usage. But again, if all you use through your Azure subscription is server management tools, you won't get billed because, again, we don't charge you at all for usage. So what are the types of capabilities we include? So fundamentally, when we started off, it's really tools that have always traditionally been local only. Things like Task Manager, Device Manager, sconfig on server core. Also, we wanted to add other commonly used tools like Registry Editor, Firewall. The next slide is going to give you a full set of the tools we support today. But essentially, think of this as an alternative to remote desktop. Right? And one of the driving factors here, of course, is that Nano Server is the direction of Windows Server in the future. It being a small footprint headless server, you don't have the ability to remote desktop into a Nano Server. And so we wanted to provide the types of capabilities and the tools that are typically used in an RDP session. It's based on WMI and PowerShell. So we leverage all of the inbox management infrastructure capabilities that are shipped in Windows Server. And what this allows us to do is it allows us to add additional capabilities over time, because there's really nothing that you need to do to update the servers that you're managing, because for the most part, the infrastructure is already there. And we build new UI capabilities on top of that infrastructure. Another advantage of being, again, a hosted service is we have the ability to go and update the service and provide new capabilities and updates a lot more frequently than a box product. So initially, the focus was really around how do we make Nano Server successful and provide a set of modern UIs representing the tools that you are used to and use on a regular basis. But as we grew this tool set out, we realized that, you know what, the value isn't just for Nano Server. It can really be used to manage other server configurations as well, including server core and server with a desktop experience. And so if you think about all the different types of servers, Windows servers that you can connect to in various network environments, all of that together in one place in one single pane of glass, that's something that we believe is really powerful. Also, given that we're targeting WMI and PowerShell, and that from the UI perspective it's web-based, you're no longer tied to a specific OS version or client for the management of specific servers. So that's one thing that has historically been a complaint with the RSAT package, which we'll get into in a little bit. But with this web-based environment, you do have the ability to essentially manage your various OS versions together. So where are we currently? So we released our initial public preview in February of this year. Since that time, we've added additional tools and functionality through two major feature updates. Again, being a cloud service, we actually update with bug fixes every couple of weeks. So there's a lot of flexibility, again, in this model, and I'm going to keep hammering on this point. So the set of tools that we support today, I'll give you a minute, or I'll give you a few seconds to kind of look this over, but it's going to look very familiar, right? Pretty much everyone in this room could look at this list and understand yeah, okay, I get what the capabilities are. I could see how, at various points in my day or throughout the week that I might use one or more of these tools to perform various management tasks, various troubleshooting tasks. And again, today, a lot of these tools either are not remotable at all, so you have to access them through RDP, or in the case of something like Event Viewer, you can actually connect to a remote server, but a lot of the time it's really, really slow just because of the type of connection. So with this tool set, we're obviously building out a set of capabilities over time, but we're never going to cover everything that you need, especially things that are not used that often, right? So in those types of scenarios, we still have PowerShell. PowerShell gives you direct remote run space locally on the target server. And from PowerShell, you do then have the ability to access all the modules and commandlets that are installed on that target server. And the management surface area then includes pretty much everything else that you would need to do, even if we don't directly surface that capability through the GUI. So before I get to the point about version support, I just want to point out that, again, it's super important for us to hear directly from our customers and to let us know what it is that you need. This is a great example because when we first released the public preview in February, we only supported and targeted Windows Server 2016 and Nano Server, obviously, because that was really the key driver of our investment. But we heard loud and clear that customers didn't see as much value in the tool set if 2016 and Nano Server was the only version that the tool set could manage. And so we took a look, and it actually turns out that it was fairly easy for us to do some additional work to support Windows Server 2012 and 2012 R2. Now, for those environments, you do need to install the Windows Management Framework 5, 5.0, or 5.1, because we do have a dependency on PowerShell 5. But that's an example of where we listened to our customers, and we said, you know what, we're going to take some time away from additional feature investments and really just bring this tool set down and make it available more broadly and make it more useful in the types of environments where our customers have mixed versions. So one of the questions I received quite a few times at the booth was, well, what about 2008 R2? We still got a lot of those, and possibly even earlier. And so my answer to that is, let us know through the user voice site, and I'll pop up the URL for that in a little bit. But this is where we need your help to help us prioritize where our investments should go and how much effort we should put into one feature versus another. I mentioned at the booth that one of the reasons we don't support 2008 R2 right now is because there are certain infrastructure dependencies that are missing or that have changed and evolved over time. And so it would take us a lot more work to support 2008 R2 than it did the amount of work we did to support 2012. But if enough customers say, you know what, it doesn't matter what capabilities you provide, it's not going to work for me unless you support 2008 and possibly lower, then that's something that we would look at the data that's aggregated across the different number of features that are requested and how many votes we get and that sort of thing to really help inform us what is the right trade-off between where we should go and what we should support. So let's talk quickly about deployment and what this looks like and how it actually connects from Azure through to your various networks. I'm going to actually show a demo of the deployment right after this slide. But first, I'm just going to give you a quick little overview of what this actually looks like. So at the booth, I had a whiteboard diagram that was a little bit more complex with more details. But I'm going to show you this and walk you through really at a higher level what this looks like and how it connects. But then we have a more detailed architecture diagram in a subsequent slide where I'll walk you through some of those other details. So really, this slide, it gives you the nutshell version, right? So the UX is hosted in the Azure portal, and this is what you as a user sees when you log into the Azure portal through your web browser. It's connected through to your infrastructure, your network, through a gateway service. The gateway model that we've adopted allows us to have a completely agentless model. So the target servers that you're managing do not have to have an agent installed. In fact, those servers do not even have to have internet connectivity themselves. Everything is brokered through the gateway. The gateway communicates to the target servers through typically standard WinRM, PowerShell, and WMI. As you see the firewall sort of picture in the diagram there. And I want to explain that a little bit because the gateway does not actually require you to punch a hole through your firewall. The gateway reaches out to the internet through standard HTTPS. So all you need is port 443. The firewall can block all other incoming traffic, and the gateway would still work because it's purely an outbound connection. So the gateway is essentially a service that you, the customer, installs on a server that you want to designate as the gateway machine. I've gotten some questions regarding, well, how heavyweight does the server need to be? What are the hardware requirements? In the demo that I'm going to show you, the gateway is actually just running on a 2-core, 4-gig VM in Azure. It really depends on how much simultaneous traffic you're going to expect to flow through the gateway. So if you're the only administrator and you've set this up for yourself, then it's not going to take much to run the gateway because really it's just a pass-through broker that proxies the requests coming from the Azure portal down to the target server you want to manage. But if you have, many administrators that you want to, allow access to your service through a single gateway, then that gateway server might, have to be a little beefier. We'll get into HA in a little bit, but we do have the ability to do scale out of the gateway as well. An alternative is you can actually set up multiple gateways. Even on the same network environment, you can have a gateway that's dedicated to serving connections for a subset of the servers, and you can set up additional gateways for serving other servers. Now, you have to deploy different gateways anyways if you have multiple network environments, because each gateway is ideally serving up the connections for the target servers, which are locally on that network to minimize the latency. So you deploy the gateway via the MSI. And again, I'm going to walk through this in a quick demo shortly. So what happens in Azure is when you want to onboard into the SMT service, you are going to create Azure resources. So similar to other Azure services, you go to the Azure Marketplace and you create something. Now, these Azure resources in the context of SMT are really just kind of pass-through objects. Unlike creating a VM on Azure where something actually happens on the back end where Azure is going to fire up an actual VM that uses, hardware resources. In the case of SMT, the gateway and the connection to the target, those are two resource types where it's very lightweight. All it does is it maps the connection between what you see in the Azure portal to the appropriate target that you want to manage on the network. So the nodes or the target connections are additional resources that are essentially attached to the gateway resource. So what this means is in Azure, when you connect and say, okay, I've created a connection to server A, the next time you connect to server A, it'll map to which gateway is serving up the connection for server A. Okay, so it's basically, think of it as a tree model where each connection that you create in Azure is essentially mapped to a specific gateway which is going to serve that connection. And so I mentioned earlier the ability to scale gateways for resiliency and performance. The way this works is you can either put it on a failover cluster and let that do the HA, or what you can do is actually just install multiple instances of a particular gateway, and it will automatically load balance and receive and process requests independently. And so if one gateway instance goes down, obviously from an HA perspective, you still have additional instances that are running and processing requests. From a load balancing perspective, that also helps with performance if you've got a lot of requests coming from several different administrators at the same time trying to manage various servers. So what I want to do with the demo is I want to split it into two separate parts. The first demo I want to show is the actual deployment flow of, okay, I've heard about this now and I'm interested. How do I get started? What do I do to actually go and provision the connection and actually start managing the servers? So in the deployment demo, what I'm going to show is how quickly and easily it is to actually even set up a test environment using Azure VMs and configure server management tools with the gateway on the Azure Virtual Network to access the Windows Server functionality of the VM and start providing management capabilities. So we'll do that, and then we'll switch back to the slides for a little bit because I want to talk about security and the overall architecture and how the pieces fit together and what flows where when. Because from the questions that I got at the booth, there's obviously a level of concern with respect to, well, this all sounds great, but how do you guys handle security? How do you ensure that any credentials that I enter are not going to be compromised? What are the sort of things that you do to help make sure that everything that gets passed through every part of the pipeline is secure and that sort of thing. So we'll get into that right after the deployment demo, and then I'm going to switch back and do a live demo of the actual capabilities of the tools themselves. Okay, so the first part is the deployment demo. And this is actually a screen capture, which I recorded previously, so I'm going to walk you through that. The reason I'm not doing the deployment demo live is because there are a couple of points where I've actually sped up the recording because I don't want you to have to sit through and wait for it while it finishes deploying, either from the Azure perspective or from the MSI install. So, I'm going to go ahead and so before I actually dive into this, I mentioned that all you need, for those of you who don't have an Azure subscription, I talked about you can either get a free trial or a pay-as-you-go subscription. Just go to azure.microsoft.com. It gives you everything you need to know to get started. And then once you have the subscription, the initial user or the owner of that subscription is the account that you use to log into the portal. So that's where we start off with this demo is I've got an Azure subscription, I've got a login account for the Azure portal, and I'm going to go ahead and log into the portal. So at various points in this walkthrough, I'm actually going to sort of pause the video and give a little bit more explanation as to what's going on. But without further ado, let's go ahead and get started. So portal.azure.com is obviously the entry point for the Microsoft Azure portal. It didn't show the login, but if you're logging in for the first time, obviously you would need to enter your credentials for the subscription in Azure. So it's already speeding up way faster than I anticipated. Let me just go back real quick. I have to remember to pause it while I talk. Apologize for that. Okay, so what you'll see here is, first of all, I've got this resource group in Azure called Ignite. A resource group in Azure is a common concept across all services. It's really a bucket of stuff, a bucket of related Azure resources that you want to typically manage together. So what I have in my Ignite resource group is a couple of Azure VMs that I've previously deployed. I've got one server, which is running Windows Server 2016 TP5. It is a server with desktop experience configuration. And I've also got a separate VM, which is running Nano Server TP5. And both of these are on the same virtual network. They are not domain joined, so it is a purely workgroup configuration. And these are on my Azure Virtual Network. And so what I'm going to do first of all is make sure that the Nano server has the WinRM port open through Azure. So you'll see this is just standard TCP port 5986, 5985. You have to do this specifically in Azure because Azure, by default, doesn't open up that port to the local network. So what this allows is, of course, because I mentioned earlier, everything goes through WinRM. When the gateway talks to the target server, obviously you want to make sure that the channel is open so that communication can actually happen. So once that's done, I'm going to go back, and what I'm going to do now is I'm going to create an SMT connection to the Nano server. Okay, so remember the name of the server. It's Ignite-Nano. So like any other Azure service, I can go to the marketplace. I can search for server management tools, and this is the primary way that you discover our service. When you find it, you've got the standard intro blurb with, again, the diagram that shows you sort of a nutshell overview of how things are connected up. Read that over. We've got some useful links at the bottom. When you click on Create, what it's going to do is ask you for some information. So the first field is the computer name. This is the name of the target server that you're going to connect to from the gateway that you will be deploying. So in our case, we're in Azure Virtual Network. We've got the name of the server I'm connecting to, which is Ignite-Nano. I'm going to use an existing resource group, which is the same resource group that contains my Azure VMs. I didn't have to do it like this. I could have created a new resource group, but because I'm sort of managing all these things together, I wanted to keep it in the same resource group. From a gateway perspective, I just named the gateway, which again is the representation in Azure, the Azure resource, for the gateway that I'm going to be deploying. So that deployment's going to happen. This is part of the video where I sped it up a little bit. And the connection experience is going to open, and the first thing that you'll see is gateway not detected. Well, that's true because I've not yet set up a gateway, and so what it's going to do is going to walk me through the process of actually deploying the gateway service on the machine, again, that I'm designating that I want to act as the SMT gateway. I have the option of specifying whether I want the gateway service to occasionally reach up and see if there's an updated version of itself and automatically update. This is the setting which is the default and the setting that we recommend because given that we're in preview, it is, there are changes that happen on a fairly frequent basis, either bug fixes, again, or new functionality. So we'd like to be able to have existing gateway deployments reach out and update itself. Now, we do understand that there are some customers who really like to fully control any and all updates, so we do have that option available as well through the manual update mode. So that's something that you decide up front, and you can choose to change later after the gateway is installed. But really, the key part of this setup process is generating a package link. Now, what this does is it takes our generic MSI installer, which contains the gateway service, and it combines it with a customized profile, which links to your specific Azure subscription ID, and it links it to the specific gateway resource instance that you just created. So this is what helps map the installation of the gateway service to always check for management tasks or requests through your specific subscription and through the specific gateway resource instance that you just created. So after it creates the package link, I'm going to go ahead and copy that URL. In this case, because I'm in Azure, I'm going to log into the Azure VM through RDP. And from here, what I can do then is download that deployment package of the gateway service on this machine, which is ignite-server. And I'm going to go ahead and save that, download it. I'm going to extract this zip file. And you'll see here you've got the MSI, and then you've got the profile.json file, which contains all the information I mentioned earlier regarding your subscription ID and the resource instance of the gateway in Azure. So we'll go ahead and run the MSI, install the service, and here what it's asking for is a certificate. So I'll get into this in a little bit when we talk about security, but from a testing perspective, you can go ahead and just use a self-signed certificate. But of course, in real scenarios, you do want to provide a real certificate here. And whichever certificate you provide here, I'll just mention briefly from a HA perspective, if you have multiple instances of the gateway, which means if you choose to install this MSI on more than a single server, then those certificates need to be the same across those different instances. But again, I'll talk more about why we use the certificate and where it's used when we get into security. So go ahead and complete the install. So one thing to keep in mind is for non-domain joined servers that you're connecting to, you've still got to get WinRM set up to communicate across the workgroup machines. So if you're familiar with WinRM, for any communication to happen, including, for example, PowerShell remoting, you do need to set the trusted hosts configuration. So what's happening here is really from the gateway, I want to say, I trust the ignite-nano server, and so that allows me to then query and get management data from that target. So once that's done, I can go back to the Azure portal. When I open up the connection now to the ignite-nano server through SMT, it's going to ask me, how do you want to connect? Right, so these are the credentials for a user account, which is in the local administrators group of the target server, in this case, ignite-nano. So I have the option of every time I connect to the server across different browser sessions, I can type in the credentials if I don't want Azure to ever save them. Or for convenience, I can choose to have Azure remember these credentials for me so that the next time I connect, it will just use those credentials. And again, from a security perspective, we're going to talk through what that looks like and how we make sure that that is secure. Once I enter the credentials that I'm going to connect as, it's going to basically have the gateway pull down this request, send it on to ignite-nano, and start pulling data up, and that populates the UI in the browser. So in the second half of the demo, which I'll come back to later, I'll go through the different capabilities of what you can do after you've got this connection set up. But first, let's talk about security. What actually just happened when I entered my credentials? So, like I mentioned, the username and password is used to execute, again, typically WMI or PowerShell over WinRM. And this is from the gateway to the target servers, okay, so against the managed nodes. If I choose to not save the credentials, what happens is, again, you're prompted every time, and the encryption happens in what we refer to as the MRP. So MRP stands for Management Resource Provider. This is really the brains behind our SMT service in Azure. If you're familiar with how Azure works, everything sits behind the Azure Resource Manager, or ARM, all resources that are provisioned and managed through Azure are sent through ARM, and each service has their own unique resource provider. And it's the resource provider that essentially has the logic to surface the tasks, management, the UI, and everything like that. So in our case, we have the management resource provider, and we encrypt the credentials that you type in before it's sent over the wire. We encrypt it using the certificate that you installed as part of the gateway deployment. We do that using the public key, part of that certificate, and so only the gateway will be able to decrypt those credentials. We also send those encrypted credentials over HTTPS, so it's doubly secure. Not only is the pipeline secure, but if you're afraid that someone compromises Azure itself, those credentials can only be decrypted by your gateway certificate. The request itself, the request being, okay, log me in, I'm going to start getting some management data. That request, which comes through the management resource provider and is sent down to the gateway. Again, it's not really sent down, it's the gateway reaching up and grabbing that request and getting that response back as part of the HTTPS call. So that payload is signed, so the gateway knows for sure that this is a valid request and it came from the real management resource provider. Okay? So what if you choose to store the credentials for convenience? We want to make sure that there's no trade-off between convenience and security. So even with the convenience of having those credentials saved, they are fully secure. So when they are stored in Azure, again, they are fully encrypted using the certificate from the gateway. The certificate never leaves your gateway, right? You have full control over that. No one else is going to be able to access your certificate through any kind of compromise of the service. And so it's fully secure. Azure itself never has access to the unencrypted version of those credentials. So that's the text form. The next slide is architecture diagram for how this actually looks in practice. So before I drill into the actual credentials and what is passed where, when, I'll just kind of explain, first of all, the various pieces. I talked already about how the user logs into the Azure portal, right? And so the login account that you use to get into the Azure portal is based on the subscription that you use. And that login is different from the credentials that are used to actually manage the target server on your network. Okay, so the login credentials of the portal user is in blue, and the credentials for the actual access of the target server is in red. So the red icon is going to animate in a little bit, but I'm going to talk about the various pieces first. So I mentioned ARM, the Azure Resource Manager. Everything in Azure goes through ARM. We've got our management resource provider, which again is the brains of our service. Some of the other Azure services that we leverage include Azure Tables. This is where we store the mapping of what the details are for any given gateway instance or connection instance. It also gives us a mapping of which target connections are associated with which gateways. And so from a single server, simple deployment perspective, that was all pretty obvious. But as soon as you get into managing multiple servers through a single gateway, or if you have multiple gateways installed on multiple networks, or if you've got multiple instances of a single gateway set up for high availability, this is where the mapping becomes really important to make sure that the routing of the requests and what is surfaced to the user in the portal is actually representative of how the administrator wanted that to be set up. We've got Redis, which we use for caching. So when you're in a browser session. The first time you enter the credentials, we will actually cache that, again, in an encrypted form, so that if you leave the browser and come back within the timeout period, you won't have to enter your creds again. And so that's purely for convenience within that browser session. And again, that cache is also used because it's not just the initial login like RDP where you authenticate once and then you're good to go for the rest of the RDP session. The way the management requests go down from the gateway to the target server is through WinRM and WMI and PowerShell. So really every request has to be authenticated. So we use that cached credential to make that connection every time. We leverage MDS, which is a monitoring and diagnostic service in Azure, and that helps us do logging. And it alerts us of any issues with the service, and it provides us good telemetry and visibility into what's going on with the service. And it helps us ensure that we can fix bugs and keep the service up and healthy. The service bus queue is what is used to essentially send messages from Azure to the gateway. So I mentioned that the gateway reaches out to Azure to your specific subscription. And so each subscription and each particular instance, particularly of the gateway that you deploy, is essentially going to have a separate queue. And the queue is what happens, if the queue is used by our service whenever there's a user request that comes in from the portal, whether you're just seeing the main page and getting performance metrics, or whether you're listing a bunch of objects like processes or services, as well as when you perform a management action. All of those are individual requests that get queued to a specific queue that is then pulled, by the gateway that is associated with that queue. Okay, so the gateway pulls and dequeues specific requests and passes it down to the appropriate target server. There's an icon here for plugins. I mentioned earlier WinRM, WMI, and PowerShell. Most of our calls, I think actually all of our calls now, go through WMI or PowerShell. But what the plugin architecture provides is the ability for either third parties or other internal Microsoft partners to have a way to access management functionality or APIs which may not yet be surfaced through WMI or PowerShell. And so by writing a plugin that interfaces with that existing API, you have the ability to then access those management capabilities as an alternative to having WMI or PowerShell be the mechanism. So that's what the plugins are. When the request comes back from the target server up through the gateway will send the data that was requested up into blob storage. Again, this is a dedicated storage account managed by the MRP specific to your subscription. And then the data then is passed back up to ARM and then through to the portal, and the data is then rendered in the appropriate controls in the web UI within the Azure portal. So that's the architecture. Let's talk quickly about credentials. So in the red, we've got the user creds that I've just typed in. Before it is sent anywhere, it is encrypted. It's passed through to ARM, to the MRP. It's cached in Redis, and it's sent down into the service bus queue, pulled down by the gateway, brokered to the appropriate target server, authenticated there, and that's where the body of the request then actually executes and the data comes back. So that's if you don't want to persist the credentials and just type it in every time. If you click the checkbox to have Azure remember your credentials, really it's very similar, but when the creds are on the gateway will encrypt those creds using the certificate again, sends it up through the blob storage, and then the encrypted version of those creds are stored not just in the Redis cache, but more permanently in the Azure tables. So let's talk about the security of the gateway. So I want to reiterate, it only reaches out using HTTPS. And so question from the booth was, well, how does that work? How does it get any data at all? So as an outbound request through HTTPS, it actually gets the request from the queue as the body of the response that comes back from that outgoing request. So it is ever only outbound communication. So again, there are no special firewall rules required. It retrieves the requests from a specific queue, again, which is mapped directly to your subscription and to the instance of the gateway resource which you created in Azure Portal. Now, there's a couple of group policies that we support to allow you to have more granular control over who does what with the SMT service. So the first group policy is whether or not gateways are even allowed. So if this group policy is set to 0, even if the gateway software is installed, it's not going to process any requests from its queue. And so the use case for this is really if you have specific servers that you want to designate to act as the gateway, and you don't want anyone else in your environment or on that particular network installing additional SMT gateways, this is a way for you to essentially say, I'm going to whitelist and have the GP setting set to 1 for the servers that I trust, that I've installed, that I intend to use as the gateway. And then with the group policy set to 0, that's configured through GP across the rest of your environment and all the other servers. None of the other servers will be able to have a functional gateway reaching out to your subscription, or any subscription for that matter. This group policy is actually agnostic to a specific Azure subscription. So the second group policy is multi-factor authentication. The Azure portal today supports this by, if you turn this on as a setting for your subscription and for the user account that is used to log into the Azure portal, Azure, if you turn this setting on, will ask you for the second factor. Okay? And so what you can do is you can set a GP that says, I'm only going to have the gateway service management requests if I know that the request came from Azure and that the user, when logged into the Azure portal, was authenticated using 2FA. So that's a summary of our architecture and security. So now what I want to do is go back to the portal and show you the actual set of capabilities that are available and what you can do from a management perspective. All right, so going back to the portal, this is a slightly different set of servers from what I showed in the deployment video, but it's very similar. I've got 2 servers in an Azure virtual network. I've got Ignite-Server 1 and Ignite-Server 2. These I previously pinned to the dashboard, and one of the advantages of being a service in Azure is that we get a lot of services for free, essentially. We don't have to do any work to implement some of the functionality. One of the things is the dashboard view in Azure Portal. You've got the ability to customize things. For example, I'm going to go and take a look at my Ignite-Server 1. And the first thing you'll see is common perf metrics like what you would see in Task Manager, CPU, memory, network, disk utilization. Let's say that I want to customize my dashboard to always show the CPU usage of this particular server because, honestly, this is the one server that I care the most about. So if I go back to my dashboard, I see it here. I can customize it in various ways. For example, what I can do is change the size. I can move it around. So if you were at the booth, you would have seen that we actually had some of these metrics pre-pinned to the dashboard. But this was one of the questions that we had at the booth is, what level of customization do we have? What level of sort of dashboard-style monitoring? Now, to be fair, it is fairly limited compared with large-scale solutions like Operations Management Suite or that sort of thing. But you do get some basic things that you can tweak and customize to your liking. So let's go back to the actual server connection. Again, one of the main goals that we have is to provide an alternative to remote desktop. Right? So we thought about, okay, what are the types of things that you do in an RDP session? And we came up with some scenarios like, okay, you've got ad hoc configuration changes. You've got troubleshooting and root cause analysis. Sometimes you just did a one-off server deployment and you've got some initial server provisioning and configuration tasks there. Right, so let's first look at the troubleshooting perspective and what you might do if something was wrong or someone told you that something was wrong with the server. At the top, you've got obviously the way to log in and choose what user account to log in and manage as. But on the left here, you've also got basic server tasks like restart the server and shut it down. Restart is great because if all else fails, restart the server. From a perf perspective, you can drill into any of these perf charts like CPU, get more details. Another question I got from the booth was, well, do we track any of this data historically? And the answer is no, this is real time. What you're seeing here is essentially what is happening right now on the target server. Unlike something like OMS or System Center, we do not have a database where we store that historical state. Now, in the future, when we move more towards multi-machine management and aggregation of data, we do recognize that there will be a need for the data to be stored somewhere centrally so that we're not pulling the data from 1,000 machines in real time all at once. So before we get there, though, what we have is a real-time set of metrics. Again, think about this as being the equivalent of Task Manager. So each of these charts are clickable. I can see additional details. For example, I can see how much memory is free, how much is used, committed, all this detail. From a networking perspective, if I've got multiple NICs, each one will show up in this list. I've got one here, so I'm going to click that, and here's going to show me the network traffic. So let's go back to the troubleshooting scenario. Typically what happens is if something is wrong with the server, maybe it's running slowly, maybe some application failed to run because it gave a out-of-memory error. So what you would do is you'd go in, okay, first you get the overview of the CPU usage. Maybe it's pegged really high, or maybe the memory usage is, I've got very little memory left. So typically what we do first is, well, let's see if there's a process that's at fault. So if I open the process list, again, this is Task Manager style functionality. I've got the ability to see all the processes. I can sort by CPU usage. I can sort by how much memory is being used, obviously alphabetically. I can search for a specific name. So everywhere in this UI where you see a list of stuff, we've got some common capabilities. One of these is filter in place, where you can quickly search and find some subset of the data that's in the list. Something else that's common is we have the ability for you to choose additional details that you want to display, such as columns. In this case, maybe what you want to see is, let's see. I'm looking for command line. So I can add more details, add more columns. I can make this wider. I can see, okay. For any given process, for example, especially for processes that have the same name like service host, I can go and see, okay, what are the actual command lines that were used to launch that process and gain some insight that way. Once I find an offending process, something that's gone rogue, I can go ahead and end that process. If I'm in a dev environment and it's a custom application, I can go ahead and create a process dump, and that will give me the opportunity to download that process dump and do some debugging and troubleshooting on that. I could run a new process. Another question I got was, well, if this is not full RDP, is there a way to install new software? And so this capability gives you a way to run, for example, installers that have a silent mode that do not pop interactive UI, and you can go ahead and get additional software installed. Or for something that's already installed, you can go ahead and run new processes from this experience. So what else do you typically do from a troubleshooting perspective? You've got services. And I just realized I am running out of time. So I'm going to quickly wrap up. If you want to see more, I'm going to be at the booth for the rest of the afternoon. I can show you additional demos and details. But unfortunately, I'm not going to be able to drill into all the details I wanted to show you. But I'll just quickly give you an overview from a services perspective. You can start and stop, restart services. Those are typical troubleshooting tasks. You've got Event Viewer, where you can see critical and error events. One thing that's interesting, which I'll point out, is Certificate Manager, because one of the things we've added here is a roll-up view, which you didn't have before of, okay, do I have any certificates that are already expired? And this pulls and aggregates data across the different certificate stores. Or any certificates that are near expiration, which is completely new, and this gives me insight into, is there anything that I might need to worry about coming up shortly? Device Manager to look at versioning information of drivers, see if any devices are operational. File Explorer gives you a view into the file system. Firewall Rules lets you edit and open up ports that you need or create new rules. If you install, for example, SQL Server that requires its own port, and go ahead and create a new rule there. From a provisioning perspective, you've got things like name the server, join the domain, and add a domain user to the local administrators group. Network settings allows you to see static or dynamic IP versus DHCP settings, and then DNS server setting that you have. And Windows Update, this is great because from a troubleshooting perspective, we heard that, okay, I want to make sure that there's not any applicable packages that have not yet been applied, and this gives me a list of what's available, a list of what has previously been installed, and I can go ahead and install now and schedule a restart for later if required.
You should show PowerShell.
And of course, last but not least, we've got PowerShell as the fallback because, again, anything that does not surface through the GUI, we want to be able to surface through PowerShell. We've got some basic ISD-style functionality, like the ability to see the list of modules and commands and commandlets and parameter sets. We've got a script editor here. And the cool thing about this is not only can you open and save scripts from the local file system on the target server, but you have the ability to open and save scripts which are hosted on the shared storage account for the subscription. And so the scenario here is you may want to have a centralized repository of your scripts that you keep up to date, and you can essentially use and load and run those scripts regardless of which target server you're managing from the target environment. So I'm just going to go ahead and quickly load this up, show you the color syntax highlighting of the script editor. And I can go ahead and run this from here. And you've got the full richness of the PowerShell execution environment, which again is a local session on the target server. So again, unfortunately, I've run out of time for this. We're going to quickly switch back. And the clicker. All right. Try it out today. Go to the Azure portal, search for server management tools. Again, for ongoing and future investments, what we need to do is provide a steady cadence of updates to provide customer value over time. Partner extensibility is really key because we want to enable this as a platform for the ecosystem. 2 key resources. We've got a blog with additional details, deployment guide. User voice, again, as Andrew mentioned earlier, super critical for you to let us know what you think, give us feedback, and provide additional input on how we should invest and where. Remote server administration tools, this is RSAT. I'm not really going to go into details here, but most of you are familiar with a package that you download, which you install on Windows Client. In this case, it'll install on Windows 10 to serve Windows Server 2016 management. And it will be released in the GA timeframe, mid to late October. The set will support management of 2016 and 2012 and 2012 R2. You've got the standard historical set of capabilities that are supported as well. And with that, I will turn it over to Andrew.
Thank you. So pretty cool new tool set, and that was going to be the focus of our session because that's the big new remote management capability we have. So I'm going to quickly cover some of the new things that are across the rest of the management surface area. There are sessions that go into more details about a lot of these technologies, and they've existed in Windows Server in previous releases for the most part. So PowerShell, story of sustained investment from 2006 V1 all the way up to the V5 that's available today in Server 2016. And so we now have, over 3,000 commandlets. If you look at a NanoServer environment, NanoServer is up over 1,000. So a lot of that's because NanoServer has a subset of functionality. Desired state configuration has a bunch of improvements. There are things around improvements in PowerShell ISE to help you author DSC. Then Pester is an open source test framework for testing your PowerShell commandlets. And so that's now available in box in Server 2016. So it's an open source technology included in Windows Server. And then moving beyond Windows, the PowerShell Gallery and Azure Automation provide a lot of capabilities and additional scripts and DSC resources and things that you can download and use in your environment. WMF5 is available. Sam mentioned this is required to install on your 2012 R2 machines that you want to use SMT to manage. And so there's a bunch of improvements that are available down level all the way down to 2008 R2 and Windows 7. And the latest is available. Like I said, it's down level. And then there's various resources available for PowerShell as well. So there's PowerShell Gallery, there's GitHub PowerShell, and then there's the Microsoft.com/PowerShell that gives you links off to all the other resources and scripts and modules and things you can download. Some other tools we've been working on is Setup and Boot Event Collection. So for those of you deploying a lot of remote servers and remote data centers, Setup and Boot Event Collection is a great way if you're provisioning new hardware and any errors occur, rather than having somebody go find that machine. I'm not sure what's going on with the lights. Now I can't see anybody anymore. It's a great way. You can actually use KDNet to stream the boot and setup events off your servers to a remote collector machine. So rather than having somebody, a server fails to boot in the data center, go find that machine, copy logs off for you, you can actually configure it to stream those events over KDNet to a collector system that you set up, and then use something like Message Analyzer to view the ETW logs. So you can even watch your systems boot and provision in real time if you want to. And so this is especially great when you're provisioning new hardware and you're not sure, it's off in some faraway data center, not sure if you've got the right drivers or the right configuration in your unattend and it keeps failing. Rather than having somebody emailing you logs or putting them on a share that you have to then go look through, and okay, let's try again, and then send them back to that machine, you can get that data locally and accessed real time, so you can see what might fail in the system. And so this works on both physical and virtual machines, so you can use it for any type of deployment. It does require a collector system, so it does require a Server 2016 machine as your collector, but that doesn't require any special hardware other than the amount of storage you need for how you configure the collector for the number of logs that it's going to store. And the logs do wrap, so you can set it up to run continuously if you wanted to and let the logs wrap, and so you can always go back and look at the history and you can control the size of those logs. I think I touched on the points there. Some other tools that we've been working on, the PowerShell team has been working on OpenSSH, and so there is a version of this downloadable that you can install on server with a desktop, server core, and it's also from the April release and on, works on NanoServer as well. So you can also use OpenSSH to remote into your machines instead of using WinRM. On the NanoServer side, we have a bunch of the sysinternals command line tools have been ported over and run on NanoServer. So there's a download you can use for the sysinternals command lines for NanoServer, so you can use those for your troubleshooting and remote management as well. System Center 2016 has a bunch of new capabilities around supporting a lot of the new features in Server 2016. So support for shielded VMs and nano server-based hosts. So both System Center VMM and System Center Operations Manager have agents available that install and work on nano server. So you can manage any of the 3 installation options from VMM or Operations Manager. Oops, wrong button. Then Operations Management Suite, OMS, Sam mentioned this a couple times. This is available to allow you to do remote administration across your entire data center environment. So it lets you centralize your logs and perform analytics on them. It lets you do Azure automation, Azure backup, as well as some things around patching and updating your systems. And then this is NanoMan. If you haven't been by the Nano Server booth, we have comic books and stickers available starring NanoMan. But just touching briefly on some of the Nano Server administration. So Nano Server, while being headless, and we created this new set of UI to manage it, you can still use your existing MMC snap-ins to manage it as well. So Server Manager available. If you use deploying a Nano Server Hyper-V host, you can use Hyper-V Manager, Failover Cluster Manager, some of the standard ones. PowerShell's available, so PowerShell Core is there. And then the server management tools that Sam talked about, those connect up and manage Nano Server as well. So really the goal with Nano Server remote management and the new set of tools we built is eliminating the need for you to ever sit in front of a server or even RDP into a server. So you have your command line, your automation and things available via PowerShell. PowerShell desired state configuration and WMI that provides integration into the DevOps tool chains with Chef and Puppet and things like that. And then in Nano Server, we have PowerShell Core. So this is a refactored PowerShell that runs on top of the Core CLR, our .NET Core framework. And so it has most of the functionality available, so it does have the full language compatibility and remoting capabilities. It has most of the core engine components, and there's a slide coming up that has some of the differences. And it supports all the different commandlet types. So what works is the core PowerShell engine, the language, PowerShell remoting, sort of all the core things you need to remotely manage. There's a few things that don't work, so the web commandlets, counter commandlets, schedule jobs, PowerShell workflow, so it cannot initiate a PowerShell workflow, but it can participate in one. And then there's a lot of information on using PowerShell Core and how to port to PowerShell Core as well. So you do have to look at your commandlets and make sure they run inside the context of the .NET Core framework. And then PowerShell Core, the PowerShell team and the Nano Server team have been hard at work on getting a lot of additional functionality into PowerShell Core. I won't go through all of these, and all of these are available in PowerShell as well. And there are some interesting ones there and very useful ones that, because of these didn't exist, it made it difficult to manage Nano Server, so we got these new commandlets created for some core functionality that have been some gaps in PowerShell over the years. So like third or fourth from the bottom, there's local users and group commandlets. So there are now PowerShell commandlets that let you create and manage users and groups, which is a great improvement. I mentioned Pester, and then down at the bottom, there are some new security commandlets as well. Because Nano Server does not have group policy, you can use DSC to push configuration out, but those security commandlets let you use a security policy that you've exported from another machine and apply that on Nano Server. Either you can do that on each machine, you could script it up as part of your deployment of a Nano Server machine, or you could use DSC to push that out and actually run the application of that policy. We're almost out of time. I was going to demo PowerShell Core, but let me go through the last couple slides, and then we'll do questions. So all this is very great, all this remote management and using a remote web-based UI. But one of the things you can change in that web-based UI is network settings. So what if you accidentally go in there and you've enter a new IP address for your server, and you made a typo and you can't remember what you set, now you can't connect anymore. Well, with Nano Server, we have a emergency management or recovery console. So you can log into this and you can see, you can go in and change your network settings. So if you've misconfigured your network, instead of redeploying the server, you can go make a fix on the machine as long as you have KVM access or BMC access. If you reconfigured a firewall rule so you can no longer connect with your remote tools, you can enable and disable those. And you can also reset WinRM or look at, if it's a Hyper-V host, the VM switch configuration as well as any VMs running on top of that, and if they're running or started or stop state. Now, In Windows Server 2016 Nano Server, the recovery console is English only and only works with US keyboards. So it does have some limitations, but we do have emergency management services support as well. And so you can also use that to connect into a machine and make fixes. And I was going to show a brief demo of that, but I'm down to 12 seconds. They're going to turn the lights back on me. So Nano Server management, it's all about cattle, not pets. Do your management remotely. Don't actually sit down and touch the server. You have PowerShell remoting, you have the web-based UI, you have existing MMCs can connect up and manage the system. So there's lots of ways to manage it. It doesn't have to be command line or PowerShell only. And then I'll throw up the call to action here. The server management tools that Sam talked extensively about and demoed, there's a link there for you to get started and try it out. Give us feedback at the other link, either server management tools or any other remote management. If there's something that's not working for you in MMC or not working in PowerShell remoting or PowerShell commandlet's missing, there are forums up there on the user voice for you to give us that feedback. And then there are some other sessions related to Nano Server and remote management and things like that this week. So I will flip back to the links and we will open it up for questions. And I think there are microphones out there, but can we turn up the lights now so we can see? Thank you very much for coming, and